My name is Daiyam Basharat, and today we'll be studying about atomic structure. So this basically refers to subatomic particles such as protons, neutrons, and electrons, and electronic configuration of different elements in the periodic table. So let's begin. So first of all, we have proton number. Proton number represents the number of protons in an atom, and each element has different number of protons, and an element is identified by its number of protons. For example, sodium is 23, and in the same period magnesium is 24. So these proton numbers increase in the according to period. So then we have, what is the mass of a proton? Mass is 1. Its mass is 1. Then it has a positive charge, and it is placed inside the nucleus. Always remember, an atom is electrically neutral, because for example, the electrons are charged. Electrons are negative, then protons are positive, and then we have neutrons with zero charge. These and these cancel out the effects of each other, and therefore the sum charge is always 0 in a atom's nucleus. And then always remember that they are attracted towards the negative pole of the nucleus. Next, we'll be studying about subatomic particles. Subatomic particles are referred to all of these protons, neutrons, and electrons. They are all known as subatomic particles. Proton and neutrons are present in a nucleus, whereas and are known as nucleons. This, you may have come across this word in the periodic table. The nucleon number, which represents the number of protons and the number of neutrons in an element. For example, we have sodium 23. That is the nucleon, the number of protons and the number of neutrons present in that specific particle, in that specific element. Then we have electrons. Electrons basically revolve around the nucleus and are present in shells that we'd also be studying later on in this video. These orbits can accommodate a definite number of electrons. These shells are known as orbits in which electrons travel, and the number of shells, if you are asked to find the number of shells present, then you use this formula, E equals 2n square, which would give you the number of shells present in a element. So this is a table that basically describes what subatomic particles have, the mass of subatomic particles and the charge of subatomic particles. So protons, they have a relative mass of +1, neutrons have a mass of 1, and electrons have a mass of 1 over 1840. Always remember this, these are round of values of masses. And then we have a charge on proton is +1, then we have 0 and -1. Then we'll be studying deflection of particles. Electrons are always attracted towards a positive pole. Protons are always attracted towards a negative pole, and neutrons, they pass through straight because they do not deflect, because they are neutral. And as I was talking about shells, this is an example of a shell of an element of a halogen, because all of its outer shell are complete. So always remember, the first shell always holds 2 electrons. The second shell holds 8 electrons only, 1, 2, 3, 4, 5, 6, and 7, 8. And afterwards, every shell after this contains only 8 electrons, or sometimes less. Electronic configuration. So electronic configuration refers to the number of electrons present in each shell. For example, the electronic configuration of hydrogen is proton number is 1, electron number is 1, and in shell 1 is 1. That's it. It has no number of neutrons. Then moving on towards sodium, for example, it has an electronic configuration of 281. That means in the first shell it has 2, then in the second shell it has 8. So these are compulsory for any element, and then they have only one other electron present in the outer shell. So this is basically electronic configuration. You can read all of these other examples that are also quoted in the diagram below. Then, for example, like I've written over here, calcium has an electronic configuration of 2882, also given over here. So in the first shell it has 2, and then it has 8, and afterwards, like I told you, after the first 2 shell, it can be more than it can be 8 or less. So 8 and then less than 8, which is 2. So most people forget about how and what an element represents. This is the element symbol. Then this is a proton number and the mass number. For for example, we have sodium, which is Na, and then we have 23 as its mass and 11 as its proton numbers. And then we have charge. With charge, always remember that number of protons do not change, but number of electrons change. For example, it has positive 1 charge, and sodium has positive 1 charge. So therefore, sodium would be represented this way, and this would not change to 10 because this represents proton numbers. Next, we'll be studying about isotopes. Isotopes are a topic frequently used by the examiner again and again over time. In both ATP, P1 and P2 and P4 papers for IGCSE and O-levels. So isotopes are basically atoms of the same element having the same number of electrons and protons but different number of neutrons. Their chemical properties are basically dependent on the number and the arrangement of electrons. They have similar properties. Then isotopes have of the same element. They're isotopes of the same element. Therefore, they have same chemical properties but different physical properties. Example: melting and boiling point. But their chemical properties will remain same. So here's an example of aluminium. This is a structure of aluminium, like we talked about the ring and everything. First 2, then we have 8 electrons in this shell, and then we have 3. This means that aluminium in the end would have Al3 positive as a charge because it has 3 electrons. The charge is dependent on the number of electrons present in the outer shell. Let's study about some more examples regarding this. For example, we have sodium. It has an electronic configuration of 2, 8 and then 1. This 1 represents the charge. This would be the charge, and this would always be positive. Always remember, if this is 8, then the element it is dependent. These two will always be same. And for sodium it would be charge 1 because this has a valence electron present in its outer shell that will bond with other non-metal elements in order to form an ionic bond. This is the brief summary of the topic we've read currently, and please go through it. I'll give you guys a minute and I'll roll this down so you guys can read what this summary has to say regarding this topic. This is an important summary, and I decided to post it as part of my video. So if you like my video, please subscribe, and I'll be posting another video regarding bonding and structure, which is topic number 3 in our course of O levels in GCE chemistry. Stay tuned.